So this is always a fun section for kids. It's the graphs of logarithms, and I may teach this differently than most people do. I teach the way that makes sense. I don't just teach push buttons in a calculator, although I do teach that at some point in time. Alright, so we're supposed to graph y equals log base 5 of 5. Now, I happen to know that if a logarithm's base equals its argument, then it's 1. So the idea behind these is to think about how I can have a 5 in here, because then I would have an output of 1. And I kind of gave you a hint over that offside on here. So since I want that to be a 5, I let x minus 3 be 5, which means that x is 8. And by the way, that doesn't create a 1 as an output for y. I kind of did that wrong. What that does is that lets me say I have a log base 5, 8 minus 3 is 5, and then minus 2. Now log base 5 of 5 is 1, so this is 1 minus 2, which is negative 1 for the output. Now the next easiest thing, next thing you want to do is you want to have a log with a 1 in it, because a log base 5 of 1 is 0, because this thing says what power of 5 creates 1, because 5 to the 0 is 1. There's a relationship between logarithms and exponentials, and that's what it is. So anyways, to get a 1 there, if x minus 3 is 1, I just add 3, and I know my x value is 4. And that gives me log base 5 of 1 minus 2. And log base 5 of 1 happens to be 0. 0 minus 2 happens to be negative 2. Now let's talk about our transformations here. We went right 3. We went down 2. And one thing you'll notice is if I went right 3, 3 plus 5 is 8. There you go. That's where you get one of the numbers. All right? 3 plus 5 is 8. Anyways, now the points that I plot are at 8, 1, which is right there, and then 4, negative 2, which is right there. This guy is a big deal. He is the vertical asymptote, and he is at x equals 3. You can't cross a vertical asymptote. And logarithms look like ours. The domain of this thing is that you are 3 to infinity, but you can't actually be 3. So hence parentheses. The range is fall forever, rise forever. I just finished grading some other function quizzes, and I do still have kids who don't understand falling forever and rising forever is negative to infinity. I don't know if they're focused on memorization or what, but they're doing it wrong. You got to read the graph, kids. Let's do another logarithm. All right, so this is a log base 2, and what I do is I want two things. I want log base 2 of 2, and I also want log base 2 of 1. Those are the two things I'm after. Now, let's talk about our shifts. Right 5. Right there. That's your vertical asymptote. Choose at x equals 5. And 5 minus 2 would be 3, but that would give me a negative 3. So that one probably ain't going to work here. I want there to be a positive 2 in there. So I know that I need to be 7. So what I'm thinking is I want x minus 5 to be a 2. I just add 5 and I get that x is 7. Now I also want x minus 5 to be a 1. So I add 5 and I get 6. And those aren't exactly in the order they need to be, but usually a table goes small to big, but whatever. So if I plug in a 7, I'll have log base 2, 7 minus 5 is 2, and then I add 3. Log base 2 of 2 is 1, 1 plus 3 is 4. If I plug in a 6, 6 minus 5 is 1, I'll have log base 2 of 1, and then plus 3. Now log base 2 of 1 is 0. If I add 3, I have a 3. Now I forgot to put in my vertical shift too. The vertical shift's not that big a deal with logarithms because it's not a horizontal asymptote or anything, but you're basically shifting the origins, all you're doing. So I'm going to contain 7, 4. I'm also going to contain 6, 3. And then I'm going to draw in my R. Domain here was 5 to infinity, range negative v to positive infinity. and moving forward with my life. Alright, let's do 6. 6 is the big one. Create a table for f of x equals twice 1/2 to the x plus 0. Since there are no shifts, the table starts at 0. So I'm going to plug in a 0 and a 1. And that's all I'm going to mess with, because it only takes 2 points if you know shapes. Now if I plug in a 0, I would have 2 times 1/2 to the 0. And anything to the 0 power is 1, so I just get a 2 back. Okay? If I plug in a 1, I'd have 2 times 1/2 to the first, which is just 2 times 1/2, which is 1. So there's my table. Now, let me go ahead and replace y with what she is. It wasn't y, she was f of x. Now create a table for the inverse. So what inverses do is they swap x and y. So I'm just going to write these values, 2 and 1, under the x column, and 0, 1 under the y column. Now, I was asked to graph both f of x and her inverse, and y equals x on the same axis. I'm just going to go ahead and do that real quick, okay? The original function contained 0, 2, and it contained 1, 1. And if you look at it, it's exponential decay. It looks something like this. And this is its horizontal asymptote. But it would look something like this, and it would flatline on the x-axis. It'd get really close to it, but it'd never touch it, okay? Her inverse contains 2, 1, and she contains 0, 1. And the old horizontal asymptote gets reflected to become a vertical asymptote. So the inverse would look something like this. And I know I'm right because I'm supposed to graph y equals x. And I only had one kid who wasn't able to graph y equals x. Just one. It's kind of sad they missed it. Anyway, step 3 is to find the inverse of f of x. So here's the original function. Step 1 is to swap x and y. So we swap them. So f of x becomes x. 1/2 becomes a y. Next easy thing to do is divide out 2. You'll notice I never divide by 1/2 because 1/2 is a base. So x over 2 is 1/2 to the y. You can go through and identify my parts. Base, exponent, argument, because bases have exponents. So I have a logarithm of base 1/2. Her argument is x over 2, and she would equal y. Last step is notation. I write the inverse of f of x. Alright, probably do 2 more. Let me pause real quick because my phone just went off. Probably my wife. So these are some of the older stuff you've done. They're not meant to be difficult, but if you don't know it, for the love of God, please ask me how to do it. I mean that. For the love of Milbrath, ask me how to do these things. As much as I don't want to do some of it because you need to practice it, I know I got to do some of it, but I'm really torn. So I think I'm going to do 9 and 10. Now 9 is a quadratic. Like, why is a quadratic on this worksheet? Well, because you hadn't done them in a while. And there are no factors of 10 that get you to 5. So you're just going to sing a little song. She goes, x equals negative b plus or minus square root b squared minus 4ac all over 2a. Now I know, judging from form quizzes, that only half of my student body knows the quadratic formula, and that is sad. Much less how to use the thing. But a is 1, b is 5, and c is negative 10. You might need another year of practice in bridge math, I don't know. The opposite of a positive 5 is a negative 5, plus or minus square root of 5 squared minus 4 times a, which was 1, times c, which is 10. Now, that's all sitting pretty over twice a 1. Now, if you square a 5, you get 25. 4 times 10 is 40. 25 minus 40 is negative 15. So we have negative 5 plus or minus the root of negative 15. And both pieces are sitting pretty over a 2. That does not look like a negative 15 there, does it? The root of negative 15 is not real, it is imaginary. And that's it, because you can't take the square root of 15. 10, old school, easy to do. We subtract 1 from both sides. We get a 12. The next easy thing to do is not to write out x minus 2 3 times. It's to divide by 3. Do not think you can use the distributive property on that. I've never shown you. Because you can't. Not until you write it out 3 times anyways. The opposite of a cube is a cubic root. The cubic root in the calculator is the 1/3 power. Now the reason I didn't use plus or minus is because that's a cubic root, and cubic roots have only one real answer. Now they can be repeated 3 times, but one real answer. And all I'm going to do is add 2 to the other side. And at that point in my life, I would go and I would push buttons in a TI-84 if I wanted to know the decimal answer. I don't have to, because I have a perfectly good answer. But if I want to know the decimal, there she is, 3.5874. And anything else you got, again, you need to ask. You need to ask. If I had more energy, I might do more. That's all you're getting out of me.